Imagine looking up at the night sky and suddenly, one star shines so bright it outshines the entire galaxy. For weeks, it becomes the most brilliant light in the heavens, visible even during the day. Then just as quickly, it fades away, leaving behind clouds of glowing gas, strange compact stars, or even black holes. This is not science fiction. This is a supernova, the death of a star, and one of the most powerful events in the universe. Today, we'll diving deep into this cosmic story. What supernovae are, how they happen, why they matter, and what they reveal about the universe and our own fragile place within it. A supernova is, quite simply, a massive star's final explosion. When a star runs out of fuel to burn, gravity wins. The star collapses, then rebounds in a catastrophic blast. For a brief period, a single star can release more energy than billions of stars combined. But not all supernovae are the same. There are two main types. Type 2 supernovae. These happen when giant stars, at least 8 times the mass of our sun, run out of fuel, collapse under their own weight, and explode. Type 1 is supernovae. These are different. They occur in binary systems where a dead star called a white dwarf steals matter from its companion. When it collects too much, it detonates in a massive thermonuclear explosion. Both types are spectacular, but they play different roles in shaping the cosmos. Humanity has witnessed supernovae for thousands of years. Ancient Chinese astronomers recorded a guest star in the year 1054. So bright it was visible in daylight for nearly a month. Today, we know that explosion created the Crab Nebula, a cloud of glowing gas and dust still expanding in space. In 1572, the Danish astronomer Tycho Brahe saw a brilliant new star appear, shaking the belief that the heavens never changed. Later, in 1604, Johannes Kepler recorded another spectacular explosion. These were not new stars. They were stars dying in a blaze of glory. Supernovae have inspired awe, fear, and curiosity throughout human history. They remind us that the sky is not static. It evolves, just like the life of stars themselves. To understand why stars explode, we must first understand how they live. Stars shine by fusing hydrogen into helium in their cores. Over time, they burn heavier elements: carbon, oxygen, silicon, and finally iron. But iron is the end of the line. It cannot produce energy through fusion. Once a star builds up an iron core, it has a ticking clock. In a fraction of a second, gravity pulls the core inward. The star collapses, then rebounds with a shockwave that rips it apart. The outer layers are hurled into space at thousands of miles per second. In the center, what remains may be a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. Or a black hole, where gravity is so strong not even light can escape. This process doesn't just destroy, it creates. The heavy elements that make up planets, oceans, and even our bodies, iron in our blood, calcium in our bones, were forged in supernovae billions of years ago. We are, quite literally, made of stardust. On February 23, 1987, astronomers witnessed the closest supernova in modern history. Named SN 1987A, it exploded in the Large Magellanic Cloud, a small galaxy orbiting the Milky Way. For the first time, scientists detected a burst of neutrinos, tiny particles that confirmed theories of stellar collapse. Telescopes around the world captured the expanding debris. Decades later, astronomers are still studying the glowing remnant, which continues to reveal secrets about how stars die. SN 1987A changed astronomy. It connected theory with observation, showing us in real time how a star can end its life. Type 1 supernovae are special because they all explode at nearly the same brightness. This makes them standard candles in astronomy, tools to measure cosmic distances. By comparing how bright they appear from Earth to how bright we know they are, scientists can calculate how far away they are. In the 1990s, astronomers studying these supernovae made a stunning discovery. Distant explosions appeared dimmer than expected. The universe wasn't slowing down, it was accelerating. This led to the idea of dark energy, a mysterious force driving the expansion of the cosmos. Supernovae and their violent deaths helped us uncover one of the greatest mysteries in physics. When the dust settles, a supernova leaves behind extraordinary objects. Neutron stars, city-sized spheres of ultradense matter. Some spin rapidly, sending out beams of radiation like cosmic lighthouses. These are pulsars, black holes, regions of space-time where gravity crushes everything into a singularity. Nebulae, expanding clouds of gas and dust, glowing with the light of nearby stars. Over millions of years, these clouds can collapse again to form new stars and planets. Supernovae are not just the end. They are part of a cosmic cycle of death and rebirth. In the constellation Orion, the red supergiant Betelgeuse looms near the end of its life. In late 2019, astronomers noticed it dimming dramatically, sparking rumors it was about to explode. While the event turned out to be caused by dust clouds, Betelgeuse will go supernova someday, whether tomorrow or in 100,000 years. When it does, it will shine as bright as the moon, visible even in daylight. It won't harm Earth, but it will be one of the most spectacular sights in human history. Without supernovae, we would not exist. They are the universe's way of recycling matter, seeding space with the elements of life. They help shape galaxies, trigger new star formation, and even guide our understanding of cosmic expansion. Every atom heavier than hydrogen and helium, carbon, oxygen, nitrogen, gold, uranium, was forged in stars and scattered by their explosions. The universe is quite literally built from the ashes of dying suns. A supernova is more than just a stellar death. It is transformation. It is creation. It is the cosmos reminding us that nothing lasts forever, but nothing is ever truly lost. When we look up at the night sky, we may see a star that has already died, its light only now reaching us. And one day, somewhere, someone may look up and see our own sun's distant descendants, the stars it helped create burning bright. The story of supernovae is the story of change, of endings and beginnings, of destruction that leads to creation. And it leaves us with one unforgettable truth. We are stardust watching the stars die, and from their ashes, life begins again.